Hello and welcome to Hadoop Diary Day 2, HDFS. So this is my second video Hadoop, and if you seen my first video, you can kind of see my format of flow. It's basically I always title the question and then I have the answer. And this is just the way I like to learn, by asking questions and getting answers. So let's get started. So on the Diary 1, I mentioned that you should use Hadoop when you want to store large files. So the question I had was, how does Hadoop store big data? They're using something called the HDFS, that stands for Hadoop Distributed File System, and it's actually much simpler than I thought. It's really not that complicated, and it just makes sense. And to best illustrate is by looking at this image. So let's say I have 256 meg file, which is on this green box. And then let's say you want to store this file into your distributed disk. And what's going to happen is, if you have a 4 computer that's in the HDFS cluster, then what's going to happen is going to store section of the file in different computer. So for example, on the first computer, it's going to contain the 64 meg, second computer 64 meg, third computer 64 meg, and fourth computer 64 meg, and all combined together should equate to the file that you actually created in the HDFS. It's really simple, right? That's what I thought. But here's the interesting twist when I read more about how it works. When it does write, it does not write in parallel. What it does is it actually writes sequentially. So 1, 2, 3, 4, 5, 6, 7, 8. It happens sequentially. And then when you actually want to retrieve the file back, it happens sequentially as well. So you're getting block 1, block 2, block 3, block 4, block 5, block 6, block 7, block 8. In Hadoop, when you actually separate a file into different segments, each segment, they call it one block. So in this case, one block equals 64 meg. And I read that in HDFS, 64 meg is the default block. So if you have 256 meg with the configuration set to 64 meg block size, then it's going to create 4. Of course, you can go into the configuration and change the block size to, say, 128. In this case, then it will only create 2 blocks. So it will only be stored in 2 files. So with that said, when I thought about this, it's like, so how does this increase the read time and write time? Because on the day 1, it said that you should use Hadoop when you want to write or read in reasonable amount of time. But as you see from here, they're reading sequentially and writing sequentially. So that is my next question. So for the single file, it does not improve copy or write speed when writing or copying a single file. So how does it do it? It does it by writing multiple files being created or copied. So if I go back, let me go back to the previous slide. So here, this is the diagram for one file. So if you want to write multiple files, what's going to happen is it's going to spawn another process to do the second file at the same time. And this is the same story for read as well. So as long as you're using the multi-thread, so basically one thread per file to read or write, then you're utilizing the write speed and the read speed. So for example, let's say, let me go back to this picture here, and let's say instead of I'm saving one file that's 256 meg, let's say I have 4 files that's 256 meg. So what I'm going to do from the client side is I'm going to run an asynchronous thread that stores all those files all at the same time. Then I'll be able to write to multiple computers at the same time. And read happens at the same time. So what that really means is that to improve the read and write speed only happens when you're trying to copy multiple files. And you need to use multi-thread. Next question is how does it handle fault tolerant? Meaning that, if you have many machines, the previous example was 3, but let's say I have 1,000 computer that stores files, and if you have 1,000 computer, there's gonna be bound to be at least one computer that will have some problem. So when that problem occurs, how does it manage? So the way they do it is, let's say go back to 256 meg file. It would separate the data. So for example, like this is the triangle, circle, and rectangle as a block. So what I mean by block is, remember I said it's supposed to be 64 meg. So if you divide it by 256 divided by 64, you should end up with 4 blocks. And of course, I just realized that I really should have drawn another shape in here to demonstrate that it's really 4 blocks, but it's 3 blocks. But it's okay. But to illustrate my point is that each block of the file gets stored in a particular data node or another computer storage. What's going to happen is it will replicate into 2 other computers, as you can see here. There's one here. There's one here. So if this computer ever fails, then you can still retrieve the entire file by these 2 computers. So I got the triangle, I got the rectangle, and I got the circle. So this is how they handle the fault tolerant. But another thing to keep in mind is that the size of the data is tripled. So because it's copying 3 times of each file block, it triples the file size. So the current size of the computer 1 is 256 meg, second computer 256 meg, third computer is 256 meg. So the total is 768 meg. So that is how it works to store a large file with fault tolerant. The next question is, I'm kind of diving into more details of this. This is still pretty high level, but I think this is good enough for me to understand and what's going on. So what these are is the actual processor. So there's a main node processor, secondary node processor, and data node processor. So for the main node server, it contains all the information on where the files are, like where the file blocks are. So if I say get me file A, it knows that I need to retrieve some blocks from the first guy. It knows retrieve a couple of blocks from the third guy, and the last one on the last data node here. Now, the secondary node is kind of like doing how do I say this best? Secondary node is not what you think it is. Secondary node, let's say name node goes down, somehow there's a problem with that, and secondary node automatically picks up when it crashes. It is not for that. What's really happening is name node is a very busy guy. As you can imagine, if there's a whole bunch of requests coming in to the name node, it needs to calculate like which node contains the data, how to write the data. Is a very busy guy. And there's some process in here that's pushed to the secondary node, so the name node does not bother with it. So one of them is, let's say, name node. When the name node gets a request to create a file, it actually has a physical file that contains that information. But name node does not write to that file immediately because that performance for that is really slow. And the guy who's handling that is secondary node. So when the request comes in, name node puts it into the memory, what that request is, performs that request, and then do the next job. And then periodically secondary node comes to the name node, retrieve all the one that's in the memory, which is something called the edit file. Edit file contains all the file changes that happen since the file metadata file that's in there. So the memory here that's in the name node is combination of the file metadata plus the edit file, which is basically file that has not been committed to the file metadata. And the guy who merges these two files is done by the secondary node. So once it merges it, then it goes back and then copies, overwrites the file metadata system. Okay, that is what secondary node does. And then there's the data node. They're just simply a processor that basically copies the file block and reads the file block, and that's all they do. So as you can see, this is the file block size right here. Now the next question is, what's name node? So name node determines how file blocks should be stored. So if you got like 256 meg size, it knows that there's 4 blocks and determines which data node should store which block. And then when you actually try to read the file, it knows where the data is. Another way of looking at name node is kind of like a boss. So boss just just tells the worker what to do. So you get a request, and he's the boss. He knows where who can handle what things. And so if the boss gets a request, give me a file A, he knows to get employee 1, 2, and 3 and retrieve the things that they need. That's the way I look at it. He is basically the boss. And as I said before, stores file metadata in memory and into a file. And the guy who actually writes the file is done by the secondary node. The next question is, what's secondary node? It is not a backup to the name node. It's really, when I look at the Google, they really said that it was a really horrible naming convention, and if they could go back, they would change it to something else. And as I said before, secondary node doesn't really, not meant for replacing name node when it crashes. It really just does a house cleaning job for the primary node, since primary node is already busy with the request coming from the client to create the file or read a file. And another way of looking at this is that I look at the secondary node as a boss assistant. So basically boss is too busy and everything else is being pushed to boss assistant to the job. Okay, next question. What's data node? Hold on for a second. Excuse me, I'm just drinking some water. Yeah, so data node is just a simple processor where it listens from name node to, to store or read a file. And it routinely updates the name node that it is still working 24/7. Um, so if the name node does not hear from particular data node for a long time, the name node will remove it from the cluster because it's going to think that worker is no longer working. So it's AKA worker. So that's the way I look at it, is AKA worker, because it notifies name node that the status of their progress and if they are still up or not. So what if the name node crashes? When that happens, the entire HDFS will be unusable. Another way of looking at it is, imagine the boss is, maybe I should have word than dead. Let's just say the boss is missing. Maybe that's what I should have used. If the boss is missing, then your entire organization might be halted until you find another boss who can replace it. But like I said, there is no replaceable name node as of right now. So there is no replaceable. So when the name node is down, it is gone. And when I actually Googled, I looked at the acronym called SPOF because this is what it says. HDF name node is SPOF. And when I looked that up, it just means single point of failure, in case you guys didn't know. Next is, what if secondary node crashes? It still functions, but it'll cause name node to perform slower over time. It'll take longer to reboot name node since secondary node has to finish all uncompleted tasks. Another way of looking at it is by not having secondary node, it'll end up with the messy boss's room. So it's gonna get messier over time. And let's say name node decides to restart everything, it won't start until boss's room is absolutely clean, which is the job of what secondary node does. So because of that, it'll take longer to reboot. But as far as being crashed in production, it'll still work fine. Like for example, can your job environment run without your assistant manager? Of course. What if data node crashes? It's okay since it has 3 copies of each file, and I mentioned that and in this slide right here. So if this server ever goes down, which is the first one, as I said before, you can still retrieve the file with combining the second one and third one because it's got all the shaping here that it needs to create the file. Alright, so that's what I learned today. So hopefully you guys learned something as well. So I'll see you guys next time.